Hey everyone, and welcome back to part 3 of your one-dimensional motion notes. This one is a lot more equation heavy, but I'm going to teach you the ways to do it by showing your work and getting all of that stuff worked out and kind of taking some of the anxiety out. Now, it looks like a lot of equations here, okay? This left side of equations are things we've been talking about. We should know that velocity is displacement divided by time. We should know that acceleration is a change in velocity over time. And yes, we need to understand that this symbol right here, this right here is a fancy little Greek symbol that is delta. Okay, that's delta. And delta is just a fancy word for change. Okay, so what this really says is a change in displacement is our final displacement minus our initial. So if something moves 16 meters, that means its delta x or its delta displacement would just be 16 meters. You'll notice like delta time over here. Okay, that just means a change in time. So if something happens over 5 seconds, that literally means the delta t is 5 seconds. Now, these four over here are what we are eventually going to call the big four on our upcoming slides. So as we go on to our next slide here, we need to make sure we understand a few things before we make that jump. First of all, we need to know that x is displacement. We need to know that a is acceleration and t is time, and we know that. We also know these words like v mean velocity, but we need to know that this word initial velocity is just a fancy word for our starting velocity. And final obviously means where it ends up. Sometimes our initial velocity will be zero by just saying we start at the top of a hill or we start at rest. Sometimes our final velocity could be zero if we come to rest or come to a stop. These are all these things that we are going to need to figure out as we do that. All right. Now, we also need to know our units. Sometimes just by looking at our units, we're able to know what variable we're talking about. Time is measured in seconds. Displacement is measured in meters. This is the dead giveaway. When it's meters per second, we're talking about velocity. When it's meters per second squared or written in this way, or remember it could be meters per second to the -2, we are talking about acceleration. So here's our big four. Okay, here's our big four. Looking at all of these variables and how we're going to use them, and we'll talk about all that coming up here in a second. All right, but there are some key things that we need to notice. This first equation right here, what is it missing? Which variable from the previous thing are we missing? You should be saying, well, there is no acceleration here. Well, that means if we look at an equation or a problem and there's no acceleration either being solved for or given to us, that might be the equation we're going to use. This one in the upper right, that one is missing. There is no t in this or no time shown in this. The one in the lower left, there is no final velocity here. And the one in the lower right, take a second, there is no displacement here. These are things that can help you as you're trying to decide which formula to use. So we're going to talk about why it's more important to know the process of finding things than just on the answer. A lot of times I'll just give you the answer. I'm really looking, can we identify the variables and can I figure out what work I'm supposed to do? So for example, if we look at this, look, I've already given you the answer. The answer is right here. The answer is going to be 115 meters per second. That's our answer. How do we get to that? Well, let's look at it real quick. If we look here and we say a car is traveling at 15 meters per second, that is our v of I, our initial velocity. It accelerates uniformly for 20 meters per second squared. That is our A. For how long? For 5 seconds. That's our T. It wants to know how fast are we traveling after this amount of time. So it wants to know how fast we're going to be traveling. That's our V of F. Okay, now let's go down and write that. Our V of I is equal to 15 meters per second. Our V of F is our question mark. We don't know that. Okay, our acceleration is 20 meters per second squared, and our time is 5 seconds. If we do that, we now have to go back and decide which formula, and this is truly the hardest one to figure out. How do we do this? How do we do this? Well, are we given a displacement at any time there? Do we know any form of displacement? Is there any x? Well, in this case, the answer is no. So we look. The first equation has an x. The second equation has x's. The third equation has an x. So this one's pretty easy. We know we're going to use this formula right here. So what we do is we go back and we write that formula without anything in it. And we say v of f equals v of I plus a t. This is important. We need to be able to write formulas without numbers in it. That will help you memorize all of these formulas. Sub it in. V of f, we don't know. V of I is 15. Plus, our acceleration is 20 times the time of 5. Simplify. V of f equals 15 plus 100. Well, if we add those two together, guess what we get? V of f is 115. Now we say that's velocity, so that's measured in meters per second. That's about all you have to do, is making sure you list your givens. Then that will tell you, and it takes practice to figure out what I have or what I'm solving for. I go back to my big four. I look at them and say, which equation am I using? And then after that, I make my choice. I hope this helps. If you have questions, make sure you reach out. See you next time.